So we're making this video in class as we prepare to take a test over the unit circle. So this is all the basics plus a couple of less basic things. So let's see how we can do with this today. Okay, so our first problems want to find, well, just values from the unit circle. So as long as you know your unit circle or have a copy in front of you, then this will make sense. And if you have no idea what the unit circle is, then Google it, right? Ask and see if you can find a copy of the unit circle. It is all the angles of 30 and 60 and 45 degrees all the way around your circle with a radius of 1. And they all have special coordinates that are really nice to use. So like sine, so at pi, so we're going to look at your angle. And at pi, we should know that the coordinate that corresponds with pi from your unit circle is -1, 0. And the sine is always the y value, so the y value on this coordinate is 0. Okay, and over here, we're going to find the cosecant, which is the reciprocal of the sine. So if the sine is 0, then the reciprocal of 0 is 1/0, which we should know is an undefined value. So the cosine at pi is undefined. Okay? And that's how we're going to go about doing all of these problems, is figuring out what the coordinate is and then writing down the either x or the y or a ratio if the case may be. Okay, so try these ones, pause the video, see if you can do them using your unit circle, and come back and we'll talk about it. Okay, so here are all of the answers. Okay, so first we found the coordinates at each of these angles in degrees or radians. And if you want the cosine, you pick the x coordinate. If you want the sine of that angle, you pick the y coordinate. And if you want a cotangent, you take the x coordinate divided by the y coordinate and simplify. If you want the secant, you take the reciprocal of the x coordinate. If you want the cosecant, you take the reciprocal of the y coordinate. And let's see, that's about it. So there's a ratio for tan and cotan, and your secant and your cosecant are reciprocals of either the cosine if it's secant, or the reciprocal of the sine if you're looking for the cosecant. Okay, so know your unit circle. All of these come from a coordinate on your unit circle. Okay, so these next couple of questions want you to find the angles. At what angle is the cosine √3/2? Okay, so think about the x coordinates. This happens at the first one, or let's see, 30 degrees. At 30 degrees, the cosine is √3/2. And that in the first quadrant, so this is the first quadrant angle. It also happens in the fourth quadrant. The cosine is positive in the fourth quadrant, and that happens at 330 degrees. So for the majority of your trig angles, there are usually two places on your unit circle where the trig has that value. Okay, two places. So don't forget to write down this second angle in this case. Okay, the sine as -√2/2. So the sine is negative in the third quadrant, and the sine is negative in the fourth quadrant. So in the third quadrant, this is a 225 degree angle where the sine has a coordinate of -√2/2. And at 315 degrees in the fourth quadrant. Okay, those are the 45 degree angles in each of your quadrants. Tangent is √3/3. Okay, let's see. That comes from a ratio where we have, let's see, what do we have? We must have a sine value of 1/2 and a cosine value of √3/2. Okay, so since that's positive, the first angle where that happens is the 30 degree angle in the first quadrant. And tan is also positive in the third quadrant. So that's going to happen at 210 degrees. You're going to have another tangent value of √3/3. Then our last one, cosine is -1. That only happens at one place, and that's at 180 degrees. Right? The negative x-axis is where the cosine has a value of -1. So let's see if we can do that same thing with these radian angles, right? These are radian angles. So the cotangent is 1. Remember, the cotan is a ratio of the x over the y. And the only way the cotan can be 1 is if your x and your y are the same. Okay, so that happens at pi over 4, where your x and your y coordinates are the same. And that happens at 5 pi over 4. So at 1 pi over 4, they're both root 2 over 2. And at 5 pi over 4, they're both negative root 2 over 2. Okay, so we have a first quadrant and a third quadrant. And last one, our cosecant is -2. That happens when the sine is -1/2, because the cosecant is the reciprocal of the sine. So if we reciprocate -2, we get -1/2. Now in the third quadrant, that's going to happen at 4 pi over 3. No, it's not going to happen at 4 pi over 3. It's going to happen at 7 pi over 6, 7 pi over 6. That's where the y value is -1/2. And then it's going to happen again in the fourth quadrant at 11 pi over 6. Those are the two angles where your cosecant is going to be -2. Okay, on to number 12. A point on the terminal side. So the terminal side is the side where the trig thing ends, right? It begins at the initial side, which is the positive x-axis, and it ends at this random point, -1, -1. Okay, so we're going to draw a line back to your origin. Okay, and this is our angle that we're making. Well, the cosecant of that angle is the same as the cosecant of the reference angle. Okay, and the reference angle is just this tiny little one right here. So in order to find that angle, the cosecant, we're going to use Pythagorean theorem to figure out what the hypotenuse is, and then relate the cosecant of any angle is the radius of your circle divided by the y coordinate. The radius divided by the y. So here our radius is root 2 units long, and your y value is -1. So root 2 over -1 becomes negative root 2. Okay, which makes good sense. Here we have basically it is a 5 pi over 4 angle, right? The 45-degree angle where your legs are the same for your right triangle. Okay, this is a 45 degrees plus 180. So that makes perfectly good sense that the answer would be negative root 2 for the cosecant. All right, let's see what else we have on the back side of our page. If I can find it. There it is. Okay, state in which quadrant the terminal side is given and find the reference angle. Okay, so for each of these, we're first going to draw a grid. So a grid like this. Okay, we always start with our initial side along the positive x-axis. And we're going to go counterclockwise 119 degrees. So the terminal side, which is this side, this is our terminal side, lies in the second quadrant. And the reference angle that we're talking about is the angle that is formed with the x-axis. So in this case, your x-axis is 180 degrees, and we have a 119-degree angle. So we have a 61-degree reference angle. Okay, and oftentimes that is called alpha, where theta is your given angle here. Okay, so that's how we're going to handle these next couple of questions. We're going to draw our coordinates. We have our initial side at the positive x-axis. We're going to go negative 352 degrees, which is almost all the way around, which is 360. And our angle ends up in the first quadrant. And the reference angle, when we drop our triangle right here, is your reference angle. 360 minus 352 is an 8-degree reference angle. So we could have reference angles in degrees if we're given degrees, or in radians if we're given radians. Okay, now 854 degrees. How many times around the circle is that? Well, I know 360 is one time around the circle, and 720 is a second time around the circle. So we have gone 134 degrees past 2 rotations. 1 rotation, 2 rotations, 134. So our 854 degree angle ends in the second quadrant. And if we drop a vertical line, we can find the reference angle, which is just the one that gets us to our x-axis. So 180 minus 134 is 46 degrees. So your reference angle is the angle that gets you to the x-axis, either positive on the right side of your y-axis or the negative x-axis over there. Okay. Now for the fun ones. What are all the trigs that will give you these answers? Okay, so think about all of the coordinates that are negative root 2 over 2. Okay, I believe that happens over here, first of all. Okay. The x value is negative at, so if I take the cosine at 3 pi over 4, right, that's the x coordinate at this angle, which is negative root 2 over 2. There's one of them. Okay, another one is if we look in the third quadrant at another 45-degree angle. Down here, both of your trigs are negative. So 5 pi over 4 and the sine at 5 pi over 4. Okay. On both of those trigs, the answer or the coordinate is negative root 2 over 2. And then the third one would happen over here in the fourth quadrant, but only to the sine, right? The sine at 7 pi over 4 is negative root 2 over 2, but the cosine is positive. So we're trying to list all the trigs and all the angles that give us negative root 2 over 2 as an answer. Okay, all of them. So think about all the ones that give you 1. Okay, so first of all, we have the cosine at 0. That gives you 1. In addition, we have the cosine at pi. That gives you 1. And if the cosine is 1, that means his reciprocal is also 1. So the secant at 0 and the secant at pi. Sorry, not pi. That's wrong. That's negative 1. Let me erase that. Bad me. The secant, that's negative 1. So the cosine of 0 and his friend, the secant at 0. Okay. If we go to the top of the unit circle, the sine at pi over 2 is 1. And because the sine is 1, his reciprocal, the cosecant at pi over 2, is also 1. So lots of 1s going on there. If we think about the ratios, every time we have a coordinate that's the same, right? The tangent at pi over 4 is positive 1. And that means his reciprocal cotan at pi over 4 is also 1. Because tan and cotan are a ratio of your x to your y. And if one of them is 1, then the other one is 1 also. And the last place is another tangent at 5 pi over 4. And his reciprocal cotan. So all 8 of these places, we have a answer that's going to be positive 1. Okay, so I'm going to pause the video and finish these up, and then I'll give you the answers in a second. Okay, there you go. Those are all the places on your unit circle where all of the trigs and all of the angles for those trigs have this given answer. Okay, kind of a lot. Sometimes it's a lot to think about. It's definitely a lot to think about. So our last questions are about, this is the word and, by the way, and coterminal angles. Okay, so if we put a graph of 8 pi over 3, okay, we're going to break our circle into 6 equal parts. Right, that's what it means to have pi over 3, dividing 180 into 3. So of course we have our x-axis here, but that's not part of our thirds. So we're going to count 8 pi over 3 to see what this angle looks like. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. So this is the angle that is 8 pi over 3. 1 revolution around our circle plus a little bit. Okay, so if we want to have a positive angle, what is this angle going to be in terms of our single revolution around the unit circle? Well, that's just 2 pi's over 3. So 2 pi over 3 is going to be our positive angle. And what if we go in a negative direction, right? What if we go this way? How many pi over 3's have I turned? Well, that's -1, -2, -3, -4 pi's over 3. Okay, so these are called coterminal angles because they have the same beginning side and the same ending side. We just aren't going all the way around our unit circle. So on 22, we have something over 5. So we're going to divide our circle into tenths. 5 on top and 5 on bottom. So 1, 2, 3, 4, and of course 180 is 5, and 6, 7, 8, 9, and then 360 is 10. Okay, where this is sort of the center of a unit circle. So -4 pi over 5 is 1, 2, 3, 4 in this direction, right? So this is -4 pi over 5 in the negative direction. So let's first talk about our positive angle. How many pi's over 5 have I gone in the positive angular direction? I've gone 1, 2, 3, 4, 5, 6. I've gone 6 pi over 5 radian angle measures. Okay, so I was given a 4 pi over 5 to begin with, which means my other negative is going to have to go all the way around, right? I'm going to have to do more than 1 revolution in order to find a negative coterminal angle. Okay, so all the way around is 10 pi over 5. So 10 pi, 11 pi, 12 pi, 13 pi, 14 pi's. -14 pi over 5 will be a coterminal angle that is also negative, right, in the negative direction. So I need to define one of each. So hopefully this has helped you review, and you're going to do fantastic on your unit circle test coming up soon.